For a long time, quantum computing felt like, well, science fiction, right? But a huge breakthrough from Google has finally dragged it out of abstract theory and into the real world. We're going to explain how they finally crossed that line and created the first useful quantum advantage. Okay, so to really get what a big deal this is, you gotta look at the timeline. This wasn't some single eureka moment. It was more like a three-step journey that started with this really powerful but kind of flawed experiment back in 2019, and it ends with a genuinely useful tool that could change, well, pretty much everything. So let's rewind the clock to 2019. This was when Google first made headlines claiming quantum supremacy, and they did. Their machine did a calculation that was, for all practical purposes, impossible for even the fastest supercomputers on the planet. On paper, it was a massive, massive deal. But here's the catch. While that 2019 experiment was a huge landmark, it had some serious problems. Think of it like you built this brilliant calculator that could solve one impossible problem, but it just spat out a random string of numbers. You couldn't check if the answer was right, and you couldn't use it for anything else. So it proved the potential was there for sure, but it wasn't a tool yet. So for quantum computing to actually become useful, it had to conquer its biggest enemy, errors. You see, quantum information is incredibly fragile, and for years, there was this fundamental paradox. The bigger and more powerful you tried to make a quantum computer, the more errors it would spit out. And this wasn't some new thing they just discovered. Nope. As Hartmut Neven from Google points out, scientists have been banging their heads against this wall for nearly 30 years. The very act of trying to make the computer more powerful was also making it more, well, broken. It was erasing its own quantum advantage. And then, in late 2024, Google's Willow chip just completely flipped the script. Now, this is where it gets really wild and kind of backwards from what you'd expect. For the first time ever, making the system bigger, going from a 3x3 grid of qubits to 5x5, then 7x7, it actually made it exponentially better. The error rate was cut in half each time they scaled up. Suddenly, their biggest weakness was on its way to becoming a strength. So, with that error problem finally starting to get under control, the stage was set for the next giant leap. This is where all those pieces finally click together to create the first truly useful calculation that's beyond anything a classical computer can do. Google's team came up with a brand new algorithm they called quantum echoes. The best way to think about it is like a quantum version of the butterfly effect. You poke a single quantum bit in one spot, and then you measure how that tiny little disturbance ripples and echoes through the whole system over time. And when they ran this new algorithm on the Willow chip, whoa, the results were just insane. It performed the calculation and estimated 13,000 times faster than the world's best supercomputers. A job that took Willow just a couple of hours would take a regular supercomputer years to finish. But here it is. This is the absolute game changer, the most important part of this whole story. Unlike that 2019 experiment, this result is verifiable. You can actually run it again and get the same answer, which proves it's correct. That repeatability, that is the absolute foundation for doing anything practical. So you might be asking, okay, great, it's fast and you can check it. But what do you do with it? Well, the first application is incredible. It's like inventing a whole new kind of microscope, but instead of seeing tiny cells, you're seeing into the quantum world itself. This new technique basically acts as a molecular ruler. It takes a technology you've probably heard of, nuclear magnetic resonance, that's the same science used in MRI machines, and it enhances it, letting scientists measure the tiny distances and positions of atoms inside a molecule with more precision than ever before. And look, this isn't just Google hyping their own work. You've got collaborators like Professor Ajoy over at UC Berkeley who are already seeing the clear path from this abstract math to real-world impacts in things like chemistry and designing new materials. And why is seeing molecules better such a big deal? Well, think about it. For medicine, it could help us figure out exactly how a new drug binds to a virus. For energy, it could help us design way more efficient batteries or better materials for solar panels. It's a fundamental tool that could unlock progress, well, just about everywhere. So yeah, this achievement is a massive milestone. It's a true turning point for the whole field. But this isn't the finish line, not even close. In fact, it's really just the launch pad for everything that comes next. The next big mountain to climb on Google's roadmap is building even more stable and robust quantum components. They're trying to create what's called a long-lived logical qubit, which, in simple terms, is like a super reliable building block for a full-scale quantum computer that can tackle a whole range of humanity's biggest problems. So the real takeaway here is profound. We've officially moved from asking if quantum computers will ever be useful to asking when and what for. This breakthrough is the very first step into that new era. We've basically been handed a new sense, a new way to see the fundamental workings of nature. The only question left is, what are we going to discover first?